All right, guys, let's talk about increasing, decreasing, and constant functions. This is all of the math speak for the functions, the different kind, okay? So with increasing functions, a function is increasing on the interval I if f of x1 is less than f of x2, whenever x1 is less than x2, for any x1 and x2 on the interval. Okay, so this is your increasing, and what that is saying is, remember that you always read the graph left to right, okay? That's really important to remember that. So going from left to right, we're going to start here. We're going to go uphill, right? Like increasing, going up. So our f of x1 is less than our f of x2. That's all that's saying. And our x1 point is less than our x2 point. So that means that it's increasing, okay? We're going uphill, going up. Now, decreasing, I guess I should have been... Decreasing on an open interval I is if f of x1 is greater than f of x2. Whenever x1 is less than x2, for any x1 and x2 on the interval. So again, reading left to right, we start up here. Now x1 is up here. It's more than or greater than x2, which is down here. And x1 is less than x2, as it was before. So this implies that we are going in a decreasing manner or downhill, right? Both start with D, if that helps you remember. Helped me in college algebra. And then constant, a constant function on an open interval I, if f of x1 is equal to f of x2 for any x1 and x2 on the interval. So we're starting here on the left-hand side, going to the right, and f of x1 and f of x2 are identically the same, then f of x1 and x2, right? So it's constant. There's no change, no slope. There's no rise over run. There's nothing. It's just the same, right? Okay. So that's constant. Here's our decreasing. Here's our constant. You can kind of think of like a roller coaster, right? So when it's going up toward its peak, that's the increase. After it's like peaked and it's going down and everybody's screaming, that's the decrease, okay? What else did I want to say here? I'm just going to say what I've already said. Always read left to right. Ooh, not what color I was wanting. It's always a surprise. All right, there's that. Let's see here. Now on this graph, we're going to look at it. We're going to see where we are increasing, decreasing, or constant. So increasing. Well, let's get a different color. Don't like that one much at all. The same exact color. I swear to Bob. All right, there you go. We're winning now. I hope. Yeah. Okay, increasing. Back to where we were. Let's talk about increasing. So we read left to right. Now we have this arrow that's going down this way. Where does this mean that we go? This arrow goes off to where? Negative infinity, okay? That is where this arrow takes us. So from negative infinity to where, what number do we make the turn and start going in a different direction? I also need to write this right here. We only care when we're doing negative, when we're doing increasing and decreasing and constant, we only care about the x's. It's important to know, huh? We only care about the x values. PA. There's an L in there, guys. Spelling. Super speller. Okay, so we only care about the x's. So from negative infinity to where? Where do we make our turn? Well, my pen just kind of magically stopped on there. -1. So down here from negative infinity, remember we can never attain that, to -1. we can see we're increasing, right? We're going uphill. Right here is our turning point. I'm going to try to make a big point there. That's a turning point. And then now we're going to start going what? Downhill, right? We're going to start decreasing. I'm going to put this over here, increasing. So negative infinity to negative 1. And we know that these are both parentheses. Why? Because we can see right here in our explanations that they are both parentheses. I mean, less than, strictly less than or greater than. So we always use parentheses. Okay, so from negative 1, we have where we make a turn, and we go to where before we make another turn. So here we turn and we start decreasing. Now I'm going to definitely pick another color. So from negative 1 to where? Right here it looks like is another one. So to positive 1, that is a 1. Now we're decreasing. I'm going to put a D here. So we're decreasing. Try to make some little things. So this is going to be negative 1. That's really a parenthesis. Sorry, guys. It's the board. Now, from this positive 1, we make a turn and we're we're increasing. So from 1, put it down here, to where? Where does this arrow say we're going? That's right. Positive infinity. You guys are so smart. Okay, so in this graph, we don't have a constant, right? Because a constant would look like just a straight line, like it would just be like that, right? We don't have a constant. So we just were increasing, then we decreased a minute, and then we took off increasing again. Okay, y'all understand that? Cool. All right, I'm going to exit the drawing, and hopefully scroll up. Ooh, my goodness gracious. Scroll up a little bit. Okay, there we go. Now let's take a minute and talk about maxima and relative maxima and minima, or local maxima and minima. I like local best. That's what I like to say, but they mean the same thing. So we'll just say that. Okay, so relative maxima and relative minima, they are y values. So the point at which a function changes its increase or decrease behavior can be used to find the relative maxima and the relative minima values of your function. Okay, more math speak. So this is the definition of relative maxima and relative minima. A function value f of a is a relative maxima of f if there exists an open interval containing a such that f of a is greater than f of x for all x not a in the open interval. And a function value f of b is a relative minimum of f if there exists an open interval containing b such that f of b is less than f of x for all x not b in the open interval. Notice that the word local can sometimes be used instead of relative. They mean the same thing, okay? It just means they're not the most extreme high or the extreme low of the graph. It's just the local or the relative one. Okay, so like here we have b, and here's our f of b. Here would be our minimum, right? Here we have our f of a, and here is a. This would be our maximum. That's all it's saying. We just go across here until we find our x value, go up and find where our y value is. Okay, not really hard. So another easier way to think about this is the relative maximum is when y is at its highest point, and the relative minimum is when y is at its lowest point. I always try to do some little simple Shelley speak that kind of, I don't know, takes all of the math speak and just kind of waters it down to where it's something easier to understand, or it is for me anyways. I hope it is for you. So there's that. I call it my simple speak. So there's that. Let's go ahead and I'm going to exit out of this and page down. All right. Let's find a couple. How about that? I wanted to color one so we can see it easily. Okay, like I said, we're going to find our x values, and then once we find our x values, we're going to go across and find our y values. All right, that's the way I like to do it. That is the way it is done, I guess. Remember, we read left to right. I mean, there's many ways to do it, actually. There's, like, it's not just my way or the highway, okay? I've just sat under many teachers, and this is the way that I found was easiest. Yeah, so here we go. We're going to find there's more than one minimum, so let's look for the first minimum, okay? I'm going to put first min, like I said. Your teacher lazy. Okay, so left to right, we go across here. Our first minimum point, I'm going to make a little circle around it, is right here. So our x value is -3. So x equals -3. Now we know that x is -3. So let's jump across here and find out what our y is. Well, it's 0, right? Because here's 1, 0, -1. So our f, we could write function notation. We learned y and f of x is the same thing. Well, our x is now named -3. So f of -3 is 0, right? When x is -3, our y is 0. All right, let's go. Now let's do it on our max. Let's see, different color for max. Yeah, blue's good. Let's do our max point. So we come to Lulu along here. What's our x when our max? Our x equals 0, right? So x is 0. So f of 0, what's our y value? We go up here and it's 4. Cool. Then we have another min value. I'm going to make him a different color. Let's do orange. And then our second min. We go over here. There's our second min. And our x equals 3. Okay. So when our f of 3, our y is 0. Okay. That makes sense to everybody? Hopefully. Okay. Now let's do this bottom one. This is a little different than what we've seen before, what I had seen before when I ran across this problem. I'm not gonna lie. What this means out the bottom is this is our scale for our x's, and this is our scale for our y's. Okay, so this means we're going to go from -4 to 4 counting by ones. Okay, so it's going to be a negative. This is going to be fun on here, isn't it? -3, -2, -1. Of course, our origin 1, 2, 3, 4. And you guys guessed it. We're going to go from -15 to 25 counting by fives. Here we go. I don't think I can write that small on here. -15, -10, -5, 5, 10, 15, 20, and 25. There we go. Did it. Winning today. Okay. Now on this one, we kind of have to estimate it, because if you go cross and you're really particular, that's the word, it's not going to be absolutely 20, but I'm going to round, okay? And this one's going to be like probably more like 7, but I'm going to say 5. So just be kind. Go with me. So I'm going to write down here, and we have a pretty green color. Ooh, though, that is not pretty. Let's see what color it is. Yeah. I wrote it funny. So those of you that are a real stickler for things, it would drive them crazy, just like estimating will. Sorry. Sick sense of humor sometimes. Okay, so we're going to go across here, and we're going to find left to right. What do we run into first, max or min? Well, you're right. It's a max. Okay, so what is our x value at that max? If you said -2, you are right. So then at our f of -2, what is our y value? 20. Approximately 20. Okay, now let's do our min. So at min, what does my x equal? 1, right on. And then f of, going too fast, aren't I? F of 1 would equal -5. Okay. Everybody cool with that? I think that may be our last page, actually. Let's check and see. Oh, it is. Holy. Okay. Well, there you go. That is what we have on that one. So I hope you guys have a great day. If you have any questions, as always, feel free to contact me. Still, I have no phone, so holler at me through email, okay? I'm about just to give y'all my cell phone number and just say good enough, okay? But anyway, holler at me through email if you have any questions, or come to our office. You know I would love that. Okay. See you soon.